Hello everyone. So in this video we are going to learn how to simplify square roots. Look, sometimes you have exercises like this, like answers, like this, square root of 144. Yep. So that means that we need to find a number which multiplied by itself results in 144. And of course, many of you already know the answer because you have encountered that number many times in your life and know which number multiplied by itself results in 144. But please follow me through this process so you will learn to do it with this example and you can learn to do it with other numbers as well. Okay, so first, what we are going to do is to make the prime factorization of the number 144. And in order to do that, we need the prime numbers. Of course, we are not going to need all of them because they are infinite, but if we remember or have the list of the first few prime numbers, it's going to be enough for most of the processes that we are going to do. So remember, the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and it goes on infinitely. But with these numbers is more than enough. So for the prime factorization, what you need is to check with the prime numbers if they can divide the 144 exactly. That means with no reminder. My recommendation is always do it in the order of the prime numbers, but if you do it in another order, it's okay as long as you don't skip any number. So let's start with the 2. Can the 144 be divided by 2? Yes. So we write it to here and the result under the 144. So 144 divided by 2 is 72. So we write it here. Now, we check again with the same number because it can also be divided by 2 in this case. So we repeat it. 2. 72 divided by 2 is 36. Can 36 be divided by 2? Again, the answer is yes. The result is 18. Can 18 be divided by 2? Yes. The result is 9. Can 9 be divided by 2? In this case, no. So the 2 doesn't work again. So we continue with the 3. Can 9 be divided by 3? Yes. And the result is 3. Can 3 be divided by 3? We don't need to check again with the 2 because if it doesn't work one time, it will not work again. Okay, so we continue with the 3 again. Yes, 3 divided by 3 is 1. And that means that we finish the process. And 144, sorry, is the product of 2 times 2 times 2. How many 2's are there? 1, 2, 3, 4. Times 2 times 3. Yes, that's the result. If we multiply these numbers, we will get 144. And how does it help us to find the square root? Okay, fine. Remember, we want a number that multiplied by itself gives you 144. So we want the square root of 144. So we want the square root of this, isn't it? Because it's just two versions of the same thing. Okay, but what happens? Remember, keep into account, here should be a 2. We don't need to write it, but there should be a 2. So that means that we need to work with the exponent 2. And if you see here, 2 by 2 is 2 squared, right? 2 by 2, again, is 2 squared. And 3, in this case, is alone. Okay? So we need to find the square root of all of this. And what happens? Square roots work in a way that let you split it if you have multiplications inside of it. So, for example, if this is a multiplication and this is a multiplication, we can split the root in this. Oh, by the way, no, 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 no. What happens? I am making a mistake. So maybe you can already tell what's my mistake. My mistake is that I am forgetting one of the threes here. Excuse me for that. Let's correct that again. Yeah, let's correct that. So times 3 times okay, but by the way, so 3 times 3 is 3 squared. Yeah. And here now we were splitting the root, so we can do it like that. And look at this really good thing that happens with square roots. You know, square roots are the opposite operation of mm, raising something to the square. Okay, what do I mean? Like, you know, for example, if you make an addition by 2, like with 2, the opposite of that is making a subtraction with 2, and these two things cancel each other, so nothing happened. If you make a multiplication by 5, the opposite of that is making a division by 5. So these two things cancel each other, so actually nothing happened. Well, if you make something squared, if you raise something to the power of 2, give me a second, let me erase this. Oh god. Okay, I was saying, if you raise something to the power of 2, the opposite is making the square root. So what happens that these two things cancel each other. And if you realize, here we have something like that. So what can we do? We can actually cancel this root with this square, this root with this square, this root with this square, and what remains? Only the 2, only the 2, and only the 3. Okay, by the way, this is equal to the previous thing, equal to the previous thing, equal to the previous thing. Okay, we cancel the roots. Yeah? And what is 2 times 2 times 3? 12, which some of you already knew is the square root of 144. Yeah? Because 12 times 12 is 144. Yep. So that way, even if you don't know the result by experience, if you don't know it by heart, you can find it. Yeah? And it's a really, really good process to find the square root when the square root is a natural number. Because not always you will find a natural number as the square root of something. This is a pretty nice example because the result is 12. But let's see what happens when we have a root that is not a natural number. So let's say that we want to find the square root of 96. Yep. So let's do the same process. Okay, remember that square root of 96 is a number that multiplied by itself is 96. So let's try to find it. Let's do the prime factorization of 96. Okay, again, prime numbers. Let me write the list again. 2, 3, 5, 7, 11, 13. Oh, by the way, I forgot the 7. Ah, no, yeah, I didn't. 17, 19, 23. I actually don't remember anymore, but usually we only need the firsts. So let's try with 2. Can the 96 be divided by 2? Yes. The result is 48. Can the 48 be divided by 2? Yes. It's 24. And can this one be divided by 2? Yes. It's 12. Can 12 be divided by 2? Yes. result is 6. Can 6 be divided by 2? Yes, the result is 3. And can 3 be divided by 2? No. So then we move to the next prime number, which is 3. And 3 can be divided by 3. Yeah, the result is 1. That means we finished the prime factorization, and 96 is the result of 2 times 2 times 2 times 2 times 2 times 3. Okay? Yeah. And since we want the square root of this, we want the square root of this. Yep. Let's do exactly what we did in the previous exercise. Let's group them by pairs. So these two are square root of, sorry, 2 times 2 is 2 squared. 2 times 2 is 2 squared. Yeah. And we don't have any other pair like of the same number. But let's anyway pair the remaining numbers, or like do this operation. What is 2 times 3? It's 6. Yep, and we have a 6 alone without any exponent, but it's not a problem. Don't worry. Okay? So we want the root of that. And remember, if there are multiplications inside a root, we can split the root. So let's do it. Let's split it with this square root of 2 squared multiplied by square root of 2 squared multiplied by square root of 6. Yeah. And remember, in the previous one, what was the next thing that we did? Cancel the roots with the squares. So we are going to do that. But we can't do it here. So what are we going to do? Look at it. Okay, here we canceled, right? So only the 2 remains. Here we cancel, only the 2 remains. And here we couldn't cancel, so we can't do anything with that. So just let's write it like it is. We were not able to cancel the root, sadly. Okay, but what else can we do? Like, can we do 2 times 2? Yeah, it's 4. And can we do square root of 6? Well, with calculator, but we don't have calculator right now. So it's just 4 multiplied by the square root of 6. And you may say, teacher, but we didn't find the result. Well, we didn't find the exact decimal number that is the square root of 96. But we found a simpler answer. Yeah, we found numbers that we can work with a little better if we want, or if we just wanted a simpler answer, we can express it this way. Because, okay, now let's use the calculator. Let's see what happens if we do square root of 96. Wait, what happened? Okay, yeah, 96 now, square root. It's 9.7979589727123 like all of that. And this is not even the whole extension of the number. The fact is that the calculator can't fit any more decimal digits, so it continues probably infinitely without any pattern that repeats. So how are you supposed to find that by hand? Well, you don't need to. There's a method, but as I told you in class, we don't usually teach it in school because it's like really extensive, and it's not just convenient. So what we do usually in math is like leaving the result expressed or simplifying it as much as we can. This is the simplification of this root. We can leave it like that. 4 multiplied by square root of 6. Yep. Also, what we can do is expressing an approximation. Look, So you saw that the result was 9 point, or sorry, I forgot again. Let me check. 96 square root. Yeah, 9 point something. Okay, so we could say, um, what is the closer numbers that we know um, have a natural square root? Like, for example, um, 1. 1 squared is 1, so no. 2. 2 squared is 4, no. So it continues with like 9, 16, 25, which is 5 times 5, 36, which is 6 times 6, um, 49, which is 7 times 7, 64, which is 8 times 8, and 81, which is 9 times 9, and 100, which is 10 times 10. But okay, we skipped, we like passed the 96. So we know it's between 9 and 10. It's over here because 9 squared is 81 and 10 squared is 100. So the 96 lies over here in a certain place. So we can say that it's 9 point something. Okay, so we can say that square root of 96 is bigger than 9 but smaller than 10. We can write it also like this as an approximation, like an estimation of what the value of the square root is. So we know it's 9 point something. We can write it like this. Or we can simplify it. And you may say, okay, teacher, but this doesn't look like 9 point something. Well, let's see what happens. Let me make this. Okay, remember, this is the approximation that the calculator gave us. So let's see what happens if we do 4 multiplied by the square root of 6. So let's do square root of 6 first. 6 square root, yeah, it's 2.44. And if we multiply it by 4, we got exactly the same result. So yeah, that's the answer. That's another version of the thing. We can write it like this, we can write it like this, or we can write it like this. Yeah, so it's really good to know that you understand how to find the simplification, how to express it like this, and also sometimes you will be lucky and you will find a natural result like we did in the first exercise. So that's it for the video, kids.